Okay, let's read the statement that you have in the question. So, do you let me know if sometime I will forget to open the mic and I'm showing you the wrong presentation. So let me know if you see something not tally with what I tell you. All right. So you read the statement above. So basically, you're given a scenario where you have a plane. Describe the path. I use the word path. So the path of the plane described by y equal to 0.001 x square meter. So again, you look at the equation, try to imagine the shape of the graph that you have. This is a quadratic equation with positive a, so it's a smiling face, right? So if the plane is rising with constant upward velocity 10 meter per second. So up to here, are you able to imagine or are you able to extract information from these two lines? First, you are given the y position, y equal to a quadratic equation. Next, it gives you a constant upward velocity of 10 meter per second. So you know that your velocity is a vector and you can expand it into three-dimensional. So you have Vx, Vy, Vz. But anyway, this will be, and you continue to read onwards. This actually you can see it as a two-dimensional problems, right? Two-dimensional problems, and it asks you to determine the magnitude of velocity and acceleration when it reaches the altitudes of y equal to 100 meter. So again, back to this statement, if the plane is rising with a constant upward velocity, so are you able to fill in this one? Your V, you have three components. V, you have Vx, Vy, Vz. So this one is what? This one should be Vy, right? Velocity going upward. So you have your Vy equal to 10 meter per second. You have your y equation, asks you to find the magnitude of the velocity and acceleration at that particular y. So to solve this kind of question, you need to draft. The behavior of the object. So you need to know how to sketch. So first, how you start with your sketch, you start with the axis and origin location with y and x. Okay, y and x. But of course, if you are not good in drawing, you can just replace the plane with a little dot to represent as a plane. Okay, important, you need to know how to transform the information above to a graph form, or we call it the position axis. So here I draw y and x axis as my reference axis, or all my direction to the x is positive, or my direction to the y is positive, and my reference point, if I use this aircraft as my drawing, the wheel, the landing wheel will be my origin, or my origin reference point. Okay. Now, how do I transform this information y equal to 0.00x square meter in this graph? It tells you that this equation is a path. So path, since the beginning, since chapter 2 and chapter 3, when I show you the path, I use blue line, right? So you can use the same line in your answer, but you can just replace it with a line. Okay, so recall what is the shape of quadratic equation of this one. Y equal to ax squared plus bx plus c, so you only have square, and the a is positive, so you have a smiling face like this. Okay, you have a smiling face, smiling curve like that, up to a point where the question asks you to stop, not stop, but asks you to analyze, which is y equal to 100 meter. So after you sketch the path, put in the equation for this path, y equal to this one. Okay, the aircraft take off, stop at that position. The question asks you at 100 meter, what is the velocity and acceleration at this point? Okay. So again, what you have a constant upper velocity, which is your Vy equal to 10 meter per second. So at y equal to 100 meter per second, what is your x? Are you able to find? This is a quadratic equation. If you plot graph, what is the value of x over here? If you know your y value. So what you do, you substitute your 100 over here. You only left out on x. You solve x squared equal to what? You solve for your x square. When you solve the square, you know that you have positive and negative value of your x, but we take the positive because your plane is moving forward in x direction. You know that your value, you will take the positive x value. You substitute inside. You get your x equal to 316.32. Plot your location on the graph. You just draw the dot line, put in the value. Okay. Now, if this one come out in your final exam, how do we give you marks? First, you read the question, transfer what you know from the question. For example, if you're able to convert this statement into Vy equal to 10 meter per second with the unit, you get 1 mark here. And there will be a section clearly asks you to sketch the motion and the path of that object. If you give me y and the x-axis, you score 1 mark. You draw the curve or the shape of the path. If you get linear equation, you draw linear equation. If you get polynomial, you draw polynomial. If you have quadratic, you draw quadratic curve. Put in the equation, you get second point, 2 mark. Okay, 1, 2. Put in the coordinate 100. Calculate what is the value of x here. You get 1 point. So basically, at this point onwards, you haven't solved your question. But up to this point, you score 1, 2, 3, 4. 4 points already. Yeah, in our module, when I become your lecturer, it's very easy to score marks. Huh? When I tell you how to score mark, you follow the steps, or you give me what I expected, you will score marks. Okay. Very easy to score marks, right? All right. Now, when you, from this information, right? From this information, velocity, what is the definition of velocity? Velocity is the rate of change of your y position, right? So y over t, dy dt equal to vy. So you can rewrite the information from velocity into another linear equation. So y equal to vyt. Okay, you know, if you know the velocity, you know the y position, you should able to find the time to reach that particular y. Okay, if you know your upward velocity is 10 meters per second and you know your location at 100 meter, you should know the time to reach from 0 to 100. Right? You always go up in a 100 meter per second. To reach 100 meter, what is the time you need to reach 100 meter? Let me ask question to the class. Okay. Sivendra, you want to try? Sivendra, you able to respond? I'm not sure whether what happened. Sivendra, are you there? Sivendra, are you there? Calling for Sivendra. Okay, I saw some response in the Teams. Okay, Sivendra, you also cannot turn on your mic, right? Correct? Okay. Okay, good. All right, so since we're having Teams issue, I'm going to continue to guide you through how you solve. All right, now this is just a derivation from V equation, velocity definition. So your V equal to dy dt, you just integrate your velocity, you go back to your position, y equal to vyt, or if you're not able to derive this one, just use your simple logic. Use your simple logic to estimate the time taken to reach 100 meter. You know that you're going up with a speed with 10 meter per second. From 0 to 100, it takes you 10 seconds, right? If you go up with a speed of 10 meter per second, how long it reach 100 meter is 10 seconds, right? So 1 second, 10 meter. So 10 seconds, you get 100 meter. So the time is 10 seconds, right? Or you derive mathematically, you use the definition of velocity, then you use integration to get back the position, like what we did in the previous chapter when we convert V versus T graph into S versus T graph. Use the same method to find the T, but anyway, you can use simple logic to solve the T. So the time is 10 seconds. Once you have the 10 seconds, okay, I expand all the information and I clear out my graph, my space here. So velocity, okay, I use chain rule. So appendix C, later I check, I'm not sure whether I already uploaded, but there's a document called appendix C about chain rules. Okay, remind me if I forget to upload this one in the Teams, remind me. So velocity, how to find velocity? You have your y equal to one equation. To find velocity, velocity in y direction is dy dt. So dy dt means you differentiate this equation 0.001 x squared, and in the equation, do you have anything linked up with x and t? Is there any? Is there anything that you can link? So on this dimension, you're not able to see anything about t. There's no t here, but you can use the chain rules that you learned in your differentiation chapter in mathematics. dy dt, when you use chain rules, what is dy dt? dy dt you can break into dy, differentiate with x, dx dt. Basically, you take out this one, you still get dy dt. But you can break into chain rules, where one side you dy dx multiply by dx dt. You continue to use chain rules. Vy equal, what is dy dx? dy dx is this equation with the y and the x. How you differentiate this equation in the y and x? Dy dx, you move your two or here, you move your 2 to the front, okay? You move your 2 to the front, copy this one, and this one index here, -1. So that's why you get 2.001x, and this one is 1. The x is t, you continue to copy by using chain rules. Okay, so you expand the answer. 2 multiply this one, you get this one. Dx dt, call back what is dx dt. Dx dt is your Vx, velocity in x direction. Okay, and what is your Vx? Right, what is your Vx? Just now you define what is your Vx, right? Let me see. Okay. Okay. I think I missed out one step here. Vx, what does mean by Vx on this graph? You use 10 seconds to reach 316.32, right? From 0 to this location, you take 10 seconds. What is the speed in x direction? Your Vx is, you take this one divided by 10, you get 31.623 meter per second. This is how you extract information from the graph. So I continue with Vx. Okay, I continue with Vx. So you know your x at 10 seconds, right? So you continue substituting value. Vy is 10, right? Vy is 10, 0.02 copy. What is your x? Your x at 10 seconds here at this location. And how do you know you are using this one? Because the question asks you to focus at the location where y equal to 100. At y equal to 100, your x is 300 something. So you substitute your x equal to 316.32. Your Vx, you can calculate, right? Okay. Okay, what else? Okay, then, so you can calculate, sorry, just now I forget to hidden this one, but the sequence after you substitute all the known value in second line of your equation, you get your Vx. Your Vx equal to 15.15.81 meter per second. So you have your Vy, you have your Vx, you can plot over here. So basically, if you want to do the vector diagram, you draw Vx, continue with Vy. How do you plot the resultant? You start from origin to the end of the arrow is your V, right? This is your resultant V direction. Okay. So magnitude, you already know, magnitude is Vx squared plus Vy squared, substitute value. You get 18.7 meter per second. Direction, when you move, rearrange this one in the vector diagram, you know that this is your resultant, and basically you are solving a triangular question. The angle you can find with tangent relationship. So inverse of your tangent dy dx, because if you move this part to here, okay, you will move this part to here, you connect the resultant arrow. Basically, this is the angle of your vector. So how you find the angle? There's a tangent relationship, opposite divided by side. You get tangent, you do the inverse, you'll get 32.31 degree. Okay, so this is your angle from here to here, and it's a vector. Huh? Remember, this one is a vector with magnitude and angle. Okay. So we continue to solve. What else we haven't solved is the acceleration. We have done velocity. We continue using the same concept with acceleration. So recall back, you have two equations you can use. Y equal to something, Vy equal to something. Okay, something that is challenging in this part is that the chain rule just now. You need to, is this one. This is the catchy part, the part that maybe you forget. Okay, so this one may be something new for you today. So this one, we are using chain rules to solve this question. We use dy dx multiplied by dx over dt. Basically, it's the same thing of dy dt. Okay, so this is where what you learn in mathematics, you apply in this module. We continue with acceleration. So there are two equations you can use. So definition of ay equal to differentiation of your velocity in y direction towards time. So dvy over dt, you get acceleration in y direction. You have an equation there. So again, you are using chain rules again. This one I think more detail. I put in here just to show you what is chain rules. Again, the detail of chain rule is in Appendix C. If I forget to upload, remind me to upload. Huh? There's an example inside there. What is chain rules? Okay, so this is a chain rules where you dt uv. How do you apply chain rules? You copy the u and then you differentiate this one, plus you copy the v, differentiate the first one. It's called chain rules. These rules also apply to the earlier session when I explained about the dx dt just now over I. I use chain rule also. Okay. This is when you use chain rules. This is the a detailed steps that you have. So if you compare, in this case, we will use u equal to 0.002x and your v is vx. Okay, meaning you are differentiating your velocity, right? You're differentiating your velocity, right? So if you compare the green color u and v to the second line of equation here, so you can see that your u actually equal to the blue color, your v equal to vx, because to find your acceleration, you're taking your y differentiation by time, right? But you're using chain rules. Chain rule means you differentiate two functions here. So you put this one side by side, you're able to see what is your u, what is your v. So your u equal to the blue color bracket, your v equal to the red color vx. And the rest, you just follow the rules that you learn in mathematics. You use chain rules. So when you have u equal to this one, v equal to this one, and you do the dv, du, this is the next steps. D over dt, your u equal to this one because of this equation. U equal to this one, v equal to this one, u, what is your u? This one, so you copy. This one equal to this one. What is your dv dt is in your x direction, ax. Why ax? Because this one is in x direction, right? Ax. And this one is vx. Okay, why we know this one is x direction? You refer back. The front one, you are looking at x. So this one is ax. This one is v. What is v? Again, refer back to the front, u and v. V is Vx, so continue to copy Vx. How to do differentiation? du dt. Du dt actually is this one. Okay. Next, we continue with the mathematics steps. Sorry, something. Yeah, correct. Okay. So this one multiply by this one, you have Vx square. Vx multiply by this one. You factor the 0.002 outside, both sides. You get 0.002 bracket. You factor this one out. You get x, ax, you get this one. This one multiply by this one, you get square. Okay. Next, you solve, continue to solve. Substituting what you get, you x at that height. This is the confirmed height, 100 meter. From your graph at the height of 100 meter, your x is 316.23. You substitute your x there. Velocity at this location, constant, 100 meter per second going up. So you know that when you have a constant velocity going up, your acceleration is 0. This is a hidden meaning that we expect you to know. You have a constant velocity, your acceleration will be 0. Because how you calculate acceleration is the rate of change of your velocity. So if the velocity remains same, your acceleration will be 0. Substitute value ay 0 because of this statement. Copy. Substitute. This one square. Vx already calculated just now. Vx. Substitute square. In this equation, only one unknown. You can solve. So ax equal to negative 0.791 meter over second. So on this graph, when I plot my acceleration, so again, there are some side note here. So ay equal to this one. So vy constant velocity in y direction means ay 0. Ax, just now you calculate this one. To find magnitude is a square root of your x, square root of your y. You substitute all this value, you will get 0.791. Direction, again, if you plot the graph of acceleration, it's a tangent of your ay divided by ax. The answer is 0. What I mean by 0? It's going along y-axis. Okay, however, just now your acceleration is negative. What I mean by negative? It goes against your reference axis. Your acceleration going back. And again, it agrees with our definition of acceleration vector with a curve, with a path just now. Okay, how you draw the acceleration arrow, we already explained. It follows the curve and the arrow always pointing toward the center of the curve. That's why the arrow, even you don't do calculation, you already know the direction of your acceleration. Okay, so from the number that you analyzed just now is negative, so basically you can know the direction is going this way. Okay, with this we end our recording. Any question?